Last time we talked about Dream Chaser, a bunch of you said the same thing. Tenacity isn't flying anytime soon, especially after NASA reshuffled the contract. But guess what? Today's update flips that whole narrative, because Tenacity is actually gearing up to fly. Yep, we finally have an update. Jeff Bezos revealed a closer look at New Glenn booster after flight. Is it damaged?
Hey, I'm Lucas. Welcome to the SpaceX community. Let's get started.
Sierra Space's long-running Dream Chaser program just reached another series of important milestones as the company continues preparing the Tenacity spaceplane for its first orbital mission, currently targeting late 2026. Over the past few weeks, Sierra Space confirmed that Tenacity has completed electromagnetic interference and compatibility testing at NASA's Kennedy Space Center, along with tow tests on the former shuttle runway to validate guidance and navigation performance ahead of the spaceplane's debut. Here, I'll go more in-depth into the new testing progress, the revised mission plan, the future of the vehicle, and what this means for Dream Chaser's transition from an ISS-focused cargo craft to a broader national security platform. The latest EMI and EMC tests verified that the spaceplane's systems do not interfere with each other or with the Falcon launch vehicle that will carry Dream Chaser into orbit. According to Sierra Space, engineers used the checkout campaign to confirm proper electrical grounding, data transmission stability, and general avionics performance during simulated operations. These results were followed by high-speed tow tests, where Tenacity was pulled down the launch and landing facility's 4.5-kilometer runway to test its runway landing sensors, brake systems, and closed-loop navigation algorithms. During these trials, the team also verified line-of-sight communications and TDRSS relay capability back to Sierra Space's Mission Control Center in Colorado. These tests are crucial for a spaceplane designed to glide to a runway landing at the end of its mission. The next major milestone is acoustic testing, scheduled for December, which will expose the spaceplane to the low-frequency, high-intensity environment produced during liftoff. The Shooting Star cargo module, which attaches to the rear of Dream Chaser, has already undergone its own acoustic trials, leaving the upcoming campaign focused primarily on the spaceplane's structural response and vibration margins. Once acoustics are complete, Sierra Space plans to ship Tenacity back to Colorado. There, the team will begin integrating modifications aimed at potential national security applications, a role that the company has increasingly emphasized since NASA agreed to modify the Commercial Resupply Services 2 contract earlier this year. Under the revised agreement, NASA now plans to use Dream Chaser for just a single demonstration mission that will not dock with the ISS, but instead perform a fully autonomous orbital test flight. The agency still has the option to order additional flights, but Sierra Space has made it clear that it intends to broaden the vehicle's use cases beyond ISS logistics. In Colorado, the company will perform propulsion system hot fire tests and full day-in-the-life operations that integrate software, avionics, ground support systems, and simulated mission timelines. Once this work is complete, Tenacity will be sent back to Florida for final launch preparations. The timing of this launch has shifted repeatedly over the last 2 years. Dream Chaser was originally planned to fly on the second mission of ULA's Vulcan rocket in late 2024, but Sierra Space voluntarily gave up that slot when ULA needed to reprioritize national security flights to maintain its certification timeline. Sierra Space has been quick to clarify that no single technical issue caused the delay. Instead, teams have worked through a range of non-conformances typical of a first-flight vehicle, while simultaneously aligning with NASA on how the spaceplane's flexible architecture should be leveraged for future missions. One of the most notable changes is the shift away from designing Tenacity's maiden flight strictly for ISS cargo operations. By not targeting the space station on this demonstration mission, Sierra Space no longer needs to complete certain safety reviews and docking verification tasks. Instead, the program can prioritize features that appeal to its emerging national security customers, which may include autonomous rendezvous capability, tactical payload delivery, and rapid turnaround mission profiles. Sierra Space officials have not detailed the specific national security use cases being explored, but the company has hinted that Dream Chaser's runway landing capability, gentle G-loads, large cargo bay, and ability to launch on short timelines could make it appealing for space-based logistics, high-value asset return, or responsive transport missions in low Earth orbit. Even as focus expands beyond NASA, Sierra Space maintains that Dream Chaser remains a multi-purpose vehicle that can support both civil and defense missions. NASA is still considered a primary customer, especially as the agency transitions from the ISS to commercial low Earth orbit destinations later in the decade. Sierra Space has repeatedly stated that Dream Chaser is well-positioned to support these future stations, and that the revised CRS contract demonstrates NASA's continued confidence in the program. The original Dream Chaser concept dates back more than 2 decades, and the vehicle has undergone a significant evolution in both design and purpose during that time. Tenacity, the first orbital-class Dream Chaser, arrived in Florida more than a year ago for what was expected to be the final testing campaign before flight. Since then, the scope of the mission has changed, national security applications have moved to the forefront, and Sierra Space has emphasized the long-term utility of a reusable lifting body spacecraft that can operate across government and commercial markets. For now, the upcoming acoustic tests, propulsion hot fires, and end-to-end software validations will determine how quickly Tenacity can be prepared for shipment back to the Cape and ultimately integrated with its Vulcan launch vehicle. As the program shifts into this next phase, Dream Chaser faces one of its most defining years yet. With national security missions emerging alongside NASA's evolving LEO plans, and with the vehicle's flight test finally nearing the horizon, Sierra Space is positioning Tenacity as a flexible, multi-role spacecraft capable of supporting a wide range of future missions. Anyways, we will have to wait and see how it progresses and the impact it has on the space industry. Quick update for you all. If you haven't joined our community yet, we'd love to have you. It's completely free, just hit the subscribe button. A few of our members mentioned yesterday that they're not receiving our daily episodes, and I'm not sure what's going on there. So, if you could do us a favor, like this video and make sure your notifications are turned on. Thank you so much, and now, let's get into our next news. Today we have even more photos and close-up views of New Glen's GS1 booster after its successful recovery from the NG2 mission. Several images shared by Jeff Bezos and observers at Port Canaveral show the booster nicknamed Never Tell Me the Odds standing tall on the Jacklyn barge and later back at the dock, giving the clearest look yet at how it held up to ascent, reentry, and a 45-second landing burn. Here I'll go more in depth into the visible condition in these pictures. What specific areas show the most wear, how it stacks up against typical Falcon 9 boosters after flight, and more. One of the most striking things right away is just how clean the entire booster looks compared to what we've become used to seeing from SpaceX recoveries. The stainless steel body is still mostly shiny and metallic with only light streaking and discoloration in a few spots. Starting from the base, the aft section around the 7BE4 engines has some expected soot buildup from the ascent and landing burns, but nothing heavy. The brown material covering the engine bay, strakes, fins, and lower interstage is the Comet thermal protection system Blue Origin left exposed instead of painting over, and it appears completely intact with no obvious ablution or melting. Higher up the vehicle, the upper barrel sections and nose cone area look essentially factory fresh with barely any marks at all. Looking closer at the large deployable strakes and grid fins, there are some darker flow patterns and minor scorch lines where plasma interacted during re-entry. But again, these are subtle compared to the deep black charring you usually see on Falcon 9 grid fins after even a single flight. The landing legs deployed cleanly and locked in place, and post-touchdown photos show the energetic welding system activated on each leg as designed, creating their small flashes and smoke puffs to bond the booster securely to the barge deck for the ride home. All 6 legs appear undamaged with no bending or heat stress visible. Jeff Bezos shared a series of photos walking right up to the booster, pointing out details like the engine nozzles, which still look pristine and ready for inspection. In one image, you can see him standing next to the base where the soot is lightest near the outer engines, and a bit more concentrated in the center. Exactly what you'd expect from methalox combustion, that burns far cleaner than RP1-LOX. There's no thick layer of carbon residue caked on like Falcon 9 routinely comes back with, and definitely none of the widespread thermal tile loss or plasma burn-through marks we've seen on early Starship test articles. When you put these New Glenn images side by side with recent Falcon 9 recoveries at Port Canaveral, The difference is night and day. Falcon 9 boosters almost always return covered in black soot from one end to the other, with grid fins charred dark, octoweb structure blackened, and often visible ablation on the heat shield areas near the engines. Even low-wear RTLS landings leave the vehicle looking battle-scarred, and high-energy expendable profile recoveries can be completely covered in residue that takes serious cleaning before refurbishment. New Glenn's Methalox propellant combined with the broader diameter strake-guided reentry profile and that Comet TPS clearly results in way less visible damage overall. Blue Origin has talked about how the cleaner burn and passive thermal protection should allow much faster turnaround times, and these photos back that up completely. The booster looks like it could theoretically be rolled back into the factory, inspected, and prepped for another flight with minimal work on the exterior. Of course, internal checks on the BE-4 engines, avionics, tanks, and hydraulics will tell the full story. But visually, this is about as gentle a first orbital recovery as anyone could hope for. We also got confirmation from the company that the conservative landing trajectory used extra propellant to keep the booster offset from the barge until the very last moments, which probably helped reduce heating and stress even further. As Jeff mentioned, they'll dial back that conservatism on future flights now that the system has proven itself, which should make landings more efficient while still keeping the hardware this clean. At this point, the booster's back at Blue Origin's facilities where teams are starting detailed inspections and teardown. Early comments suggest it's in excellent shape internally too, with engines showing expected but manageable wear. If everything checks out, there's real talk of flying this exact GS1 again as soon as NG3 or NG4, which would be an incredibly quick reuse turnaround for such a large vehicle. For the first time, we have high-resolution proof of just how much cleaner Methalox reusability can be in practice. New Glenn's GS1 came through its debut flight and recovery looking barely flown at all, a huge contrast to the soot-covered workhorse appearance of Falcon 9 boosters after similar missions. This is a massive win for Blue Origin's design choices, and sets a strong foundation for the rapid reuse cadence they're aiming for. We will have to wait and see how the internal data looks and how quickly they can turn this hardware around. But these photos already speak volumes about where New Glenn stands in the reusability game.
Thanks for watching today's episode. Don't forget to subscribe and give us a thumbs up if you enjoyed it. Stay tuned for another great video tomorrow.